Hello everyone, this is Shravani Kotamkundla. Today I am going to explain about random process and its classifications. Introduction to random process. A random process or a stochastic process is a collection of a random variables indexed by time. Each sample path represents a possible outcome and random processes model time varying uncertain signals. Importance of a random variable. It is used in communication systems, finance, biology and weather forecasting, and it is also helps in analyzing certain signals and noise. And finally, it is useful for predicting systems behavior under a randomness. Basic terms: sample space, set of all possible outcomes, and random variable, a mapping from a sampling space to real numbers. Random processes, a set of random variables over a time. Mathematical expression: x of t comma tau is a random process. T is a time variable and outcome omega is the outcome from sample space. For each omega, x comma t comma omega is a time function or a sample function. Each realization of a random process is a sample function. And example for sample function is noise signal measured over a specific period. It represents one possible behavior of the process. Classification of the random process. It can be classified based on time and sample space nature, statistical properties, stationary and ergodicity. Based on time and sample space, discrete time random process. It the time takes discrete values. And continuous random process. Time is continuous. Discrete random process and amplitude is discrete. And finally, continuous state random process. Amplitude continuous. Examples. Examples. Example for discrete time. Daily stock prices samples. Continuous time. Voltage of a noise signal. For discrete state, coin toss outcomes. And finally, for continuous state, temperature over a time. Based on statistical order, first order process, statistics of one variable, and second order processes, joint statistics of two variables, nth order processes, joint behavior of n random variables. Mean function. Mean. Mean is represented mx of t, that is equals to expectation of x of t. It represents the expected value at the particular time. For stationary processes, mean is constant. And autocorrelation function xxx t1 comma t2, that is equals to expectation of x1 of t1 into x2 of t2. It measures similarity between two values of a random process at different times. Importance for power spectral analysis. Cross correlation function x comma y of t1 comma t2, that is equals to, it is the expectation of x1 of t1 and into y2 of t2. It measures cross correlation between different random processes. And stationary processes, properties independent of time shift. It is also called as SSS, strict sense stationary. In SSS, all orders statistics unchanged. Wide sense stationary WSS, In weights and stationary, mean constant and autocorrelation depends on time difference only. Non-stationary processes. Statistical properties changes with time. Example for non-stationary processes is speech signals, stock market trends. Hard, harder to model and predict. And ergodic processes. It is its time averages equal assemble averages. A signal realization can represent the whole processes. It is also used in a practical measurements. Gaussian processes. Every set of random variables has a joint Gaussian distribution and completely described by its mean and autocorrelation. Example for Gaussian process is thermal noise in circuits. Poisson processes counts the number of events in a fixed interval. Events occurs randomly and independently. Example for Poisson processes is arrival of a customer or a data packets. Applications of a random process. Communication system, noise analysis, financial modeling, control systems and robotics, weather and population studies, signal and image processing, etc. Thank you for watching my video. I hope you understand well.